Where is everyone? In a universe this vast, why does it feel like we're alone? Billions of stars, endless possibilities, and yet, silence. Look up, really look. What do you see staring back at you? We scan the skies for a sign, a whisper, anything. But all we find is emptiness. A city with no crowd, a universe with no answer, the Fermi Paradox, the greatest cosmic mystery. If life should be everywhere, why is it nowhere? Stars, billions upon billions of them, clustered together just in our own Milky Way galaxy. Each one a distant sun, burning with unimaginable power. And our galaxy, vast as it is only one among hundreds of billions of other galaxies scattered throughout the observable universe. Each galaxy a swirling island of stars. Each star is a sun, potentially with its own retinue of planets, moons, and asteroids, orbiting in a delicate cosmic dance. Given these numbers, statistically speaking, the universe should be absolutely teeming with life. From simple microbes to complex civilizations, it should be a cosmic metropolis, a vibrant and bustling network of civilizations, each with its own unique history and culture. So here's the big question, the one that has haunted scientists and philosophers for decades. If the universe is so unimaginably vast and old, and the basic ingredients for life are seemingly everywhere, then where is everybody else? Why haven't we heard from anyone? We've been listening intently for decades using powerful radio telescopes to scan the skies, hoping to intercept a signal, a cosmic hello, a sign that we are not alone. But all we've heard so far is an unsettling silence, a profound and echoing emptiness. This isn't just a simple scientific curiosity, it's a deep and fundamental puzzle about our place, our significance, in the grand cosmic scheme of things. Imagine standing in the middle of Times Square on New Year's Eve. You're expecting a massive crowd, a cacophony of sounds, a vibrant celebration, but instead, you find only silence, emptiness, and deserted streets. An eerie and unsettling stillness. That's a little bit of what the universe feels like right now. A vast, potentially crowded space that is strangely, eerily, silent. The silence itself is a clue, a deafening anomaly, and in its own way, it's screaming at us, begging us to understand. This profound mystery, this cosmic silence has a name. It's known as the Fermi Paradox. It's not just a scientific problem, it's deeply philosophical, forcing us to confront fundamental questions about existence, touching on the nature of intelligence, the potential for self-destruction, and ultimately, the fate of our own future. Are we the first intelligent species to emerge in the universe, the last survivors of some unknown cosmic catastrophe, or are we simply so insignificant, so unremarkable that no one has even bothered to notice us amidst the cosmic immensity? The quest to answer this profound question is undoubtedly one of science's greatest and most important adventures. The Fermi Paradox is a clash of two powerful, seemingly contradictory ideas. It's a head-on collision between what we think should be, based on our understanding of the universe, and what we actually observe. It's a puzzle that has captivated scientists, philosophers, and thinkers for decades, challenging our assumptions about our place in the cosmos. First, the argument for abundance. The sheer, overwhelming scale of the universe suggests that life should be common. Our sun is, in itself, remarkably average. It's not particularly large, bright, or unusual in any way. And the Milky Way, our home galaxy, is estimated to contain hundreds of billions of stars, and we now know that most of these stars are orbited by planets. Furthermore, many of these planets reside within the habitable zone, that Goldilocks region around a star where temperatures are just right for liquid water to exist on the surface, a crucial ingredient for life as we know it. The numbers involved are truly staggering, almost incomprehensible. We're talking about billions upon billions of opportunities for life to emerge. So, even if only a tiny, minuscule fraction of these planets actually manage to develop intelligent life, the galaxy should, statistically speaking, be teeming with civilizations. It should be a vibrant, bustling network of intelligent species, and the universe has had a vast amount of time, 13.8 billion years to be precise, for life to not only arise but also to evolve, develop advanced technologies, and potentially spread throughout the cosmos. A civilization just 1 million years older than us, a mere blink of an eye in cosmic terms, could possess technology so far beyond our comprehension that it would seem like magic. On the other hand, there's the argument from evidence, or more accurately, the distinct lack of it. Despite all the theoretical possibilities, we haven't found any concrete proof of extraterrestrial life. Where are the alien probes, the self-replicating explorers that a sufficiently advanced civilization might send out to map the galaxy? Where are the megastructures, the Dyson spheres, or other colossal engineering projects that would be visible across interstellar distances? Where are the radio signals, the deliberate or accidental transmissions that might betray the presence of another intelligent species? We've dedicated decades to the search, with ambitious projects like SETI, the search for extraterrestrial intelligence, constantly scanning the skies for any sign of an alien civilization, but so far, we've found nothing. Absolutely nothing. Just the faint, ever-present background hiss of the cosmos, the static of the universe itself. This, in essence, is the heart of the Fermi Paradox. The profound and unsettling contradiction between the high probability of extraterrestrial life and the complete and utter lack of any evidence for it. A universe that, by all accounts, should be teeming with life yet appears to be eerily silent and empty. It's a cosmic mystery of the highest order, a question mark hanging over our understanding of the universe. A mystery that forces us to fundamentally rethink everything we thought we knew about life, intelligence, and our place in the grand cosmic scheme. The universe, in its vastness and silence, seems to be asking us a profound question. Are you absolutely sure you understand how I work? Are you certain that your assumptions about life and the universe are correct? And for now, the contradiction remains stubbornly unsolved, a tantalizing enigma that continues to drive our exploration of the cosmos. The Fermi Paradox got its name in 1950. This took place at Los Alamos National Laboratory. Physicist Enrico Fermi, famous for his quick calculations, was casually chatting with colleagues about UFOs and the possibility of alien life. In the middle of lunch, Fermi suddenly and pointedly asked, "But where is everybody?" He'd done the math. With so many stars and so much time, we should see some evidence of alien civilizations. The galaxy should be teeming with probes, signals, and of course colonized worlds. Yet Earth seems untouched, unvisited, and alone. That simple question perfectly framed this cosmic puzzle. The Fermi Paradox was born at a simple lunch table, and it continues to haunt us even today. One explanation for the Fermi Paradox is that we are in fact alone. This is the rare Earth hypothesis. Simple life might be common but complex. Intelligent life is extraordinarily rare. Earth's conditions are a cosmic jackpot, large moon magnetic field plate tectonics, and a safe galactic neighborhood. Maybe each step toward intelligence is a great filter, a nearly impossible barrier. The filter could be the jump from chemicals to life, or from simple to complex cells, or surviving our own technology. If the great filter is behind us, we're incredibly lucky. But if we're truly alone, the silence isn't a puzzle, it's reality. The hopes of all life in this corner of the universe rest on us. Our existence would be precious and profoundly lonely. The universe could be a vast empty stage and we're the only actors. It's a humbling, even terrifying thought. The responsibility is immense. Are we ready for it? What if aliens are out there but hiding? This is the zoo hypothesis. Advanced civilizations might be observing us, letting us develop naturally, like animals in a preserve. It's the prime directive from Star Trek: don't interfere with less advanced societies. Contact with a superior culture could destroy ours, just as it has with isolated tribes on Earth. Maybe they're waiting for us to reach a milestone. World peace, sustainable energy, or interstellar travel. The silence isn't absence, it's a deliberate policy. We're not alone, we're in quarantine. The galaxy isn't empty, it's respecting our privacy. The lack of evidence is evidence of a successful galaxy-wide policy of concealment. We might be on the verge of joining a much larger community. The cosmic zoo could be real. Maybe the universe is still young and we're the first to arrive. Early on, the cosmos was violent, massive stars exploded, sterilizing space. It took billions of years for things to calm down, for heavy elements to form, and for planets like Earth to appear. The cosmic habitable era may have only just begun. Our solar system could be among the first with the right conditions for life. If so, there are no ancient civilizations, just us, the pioneers. The great filter might not be in our past, but in the universe's timeline. If we're the first, we're the universe's first attempt at self-awareness. The future of intelligence could depend on our choices. We might be living the first chapter of cosmic history. The responsibility is ours. What if we're searching for the wrong things? What if our assumptions about alien life are fundamentally flawed? Or are we simply too primitive to recognize alien life, even if it's right in front of us? Perhaps we lack the cognitive tools, the scientific understanding to decipher its existence. Alien life could be so radically different from anything we've ever encountered that we wouldn't even know it if we saw it. Its biology, its communication methods, its very essence might be beyond our current comprehension. We look for radio signals, diligently scanning the cosmos for patterns and anomalies. But advanced civilizations might use technologies so far beyond our current grasp that we can't even imagine them. Their methods of communication, their energy sources, their very existence could be undetectable by our current instruments. Imagine explaining a smartphone to a Roman centurion, a device that embodies concepts of instant communication, global information access, and complex computation. The gap between our understanding and that of a truly advanced alien civilization could be even greater, spanning not just centuries, but eons of technological and intellectual evolution. Aliens might not be biological at all. Their forms could be something entirely different from what we expect. They could exist as pure energy, beings of plasma and light, entities that manipulate the very fabric of space-time. Perhaps they are forms of consciousness, existing as information patterns within vast cosmic networks, or as distributed intelligences spread across multiple dimensions. Arthur C. Clarke famously said, "Any sufficiently advanced technology is indistinguishable from magic." Maybe what we perceive as immutable natural laws, the very foundations of our understanding of the universe, are actually the deliberate work of a super-advanced civilization, shaping reality to their own purposes. The silence we perceive in the cosmos might not be emptiness, but a symphony we can't yet hear, a complex and intricate composition played on instruments beyond our current comprehension. This is perhaps the most humbling explanation of all, a stark reminder of our place in the universe. We're cosmic infants, barely beginning to grasp the immensity and complexity of the universe, largely unaware of its true nature and the forces that shape it. The Fermi Paradox, the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of contact, may simply reflect our own profound ignorance. We must keep questioning our assumptions, searching with open minds, and constantly expanding our senses and our understanding of the universe. The universe, in its infinite vastness and complexity, isn't obligated to make sense to us, to conform to our limited perspectives and expectations. So, keep looking up, keep wondering, and keep pushing the boundaries of human knowledge.